what if I tell you that a simple water-methanol mixture can completely change its composition during distillation, even though we never add more feed? And what if you could watch that entire separation dynamically inside Aspen Plus? In this video, I will show you how to simulate batch distillation column step by step, and more importantly, how to analyze temperature changes, receiver composition, and pot composition over time. If you are learning process simulation, Aspen Plus, or distillation design, this tutorial will help you understand how real batch separation behaves inside a column. Let's get started. Hello everyone, and welcome back to the Chemical Engineering and Aspen channel. In our today's video, we are going to learn how to simulate a batch distillation process in Aspen Plus. Batch distillation is widely used in industries such as pharmaceuticals, specialty chemicals, and small-scale separations where feed composition changes over time or when continuous process is not economical. In this tutorial, we will simulate the separation of a water-methanol mixture using a batch distillation column and analyze important results such as temperature profile in the column, composition of the receiver with time, the composition changes inside the pot. This V1 represents the pot, this is the receiver part, this is the column, and this COL represents the contents inside the pot. So if you want to understand how batch distillation behaves dynamically in Aspen Plus, make sure to watch this video till the end. So we have been given the charge specification that the feed which is fed to the batch distillation or charge which is fed to the column is at a temperature of 20 degrees centigrade, pressure of 1.01325 bar, and the molar flow rate of the charge or the molar amount is 18 kmol per hour, which is including the mole fraction of methanol as 0.4 while that of water as 0.6. In column specifications, it has been given that the total number of stages are 10. The pot heat transfer is rigorous. The initial condition for the operation of the batch distillation column is total reflux. The column DP, the pressure drop is 0.1 bar. The reflux from liquid holdup is 0.02 cubic meter. Stage holdup is 0.005 cubic meter from second to ninth stage. The first stage represents the condenser, which is installed, and the 10th stage represents the pot, while the condenser type is total. Furthermore, we have been given that the pot orientation is vertical, the top and bottom both are elliptical, the 10-10 length is 1 meter, while the volume is 0.8 cubic meter. Also, we have been given that the reflux ratio is 1.1 and the jacket heating duty is 150 kilowatt. So using this information, we will now go to the Aspen Plus and we will simulate the batch distillation process to see how much separation we can achieve in the column, and then we will further discuss the results. So first thing is to add the component methanol and water are added. Then we will click on this next button and we will select NRTL as our thermodynamic property package. Again, clicking on next, and we will run the simulation. And once results are available, we will move to the simulation environment. And in batch models, this batch separation equipment is placed. Rigorous batch distillation column for separation of 2 or 3-phase mixtures. So we will click it, we will place it over here, and then we will do the connections. Now there are 3 red connections, pot charge. So this is our charge which is fed to the column. This is the final column contents after the separation, which represents that how much change has been occurred over here and what is the final composition over here. And this represents the distillate stream, or we can say it as a receiver stream. So clicking on this S1, which is our charge, and that is 20 degrees centigrade, 1.01325 bar, 18 kmol per hour, while the mole composition or mole fraction for methanol is 0.4, while that of water is 0.6. Then we will go to the column and we have to go here step by step to all our points. First one is the configuration. It is a batch distillation column because we are simulating the complete column. The total number of stages are 10. The valid phase is vapor liquid. In overhead, it is total condenser and reflux drum is present. So you can see this is the condenser, this is the reflux drum, this is the column, this is pot, and this is the receiver number 1. And in pressure and holdups, we will obviously specify it. Pot heat transfer is rigorous and initial condition is total reflux as we have discussed. Now we will go to the streams, and in product stream, obviously it is S3, which is this one. Then in pressure and holdups calculations options specified. The condenser pressure is 1.01325 bar. By default, it is zero point 0.1, and we are taking it as 0.1. And in holdup, we will select it as volumetric cubic meter. That is 0.02 cubic meter. The start stage is 2. The end stage is 9. As I have told you that if it is 10, one of the stage represents the pot and the other stage represents the condenser. So the actual stage from 2 to 9, and that is 0.005 cubic meter. Then we will come to the condenser. No need to specify something here. Everything is okay. Going to the pot, and here we have to specify that the pot orientation is vertical. The head type, top and bottom both are elliptical. Here we will specify 10 length and volume. So in volume we will specify it as 0.8 cubic meter. And in 10 length, which represents this one, is 1 meter. We have now specified everything here about the overall configuration, the streams, the pressure and holdup, spot, and in reflux, we will specify it as 1.1 as it has been given to us. So if you click on this column, for example, it will directly take you to the configuration part. If you click on this spot, it will take you to this part in receiver, accordingly in streams, in condenser, it will take you here, and in reflux, it will take you here. Then going to the heat transfer, because there are few parts which we have to specify as well. Heat transfer method is rigorous, and in jacket heating, we have to specify the duty. So the specified duty in kilowatt is 150 as it has been given to us. Then in initial conditions, we have to specify the charge. Total initial charge is 18 kmol per hour. And then in operating steps, we will click on this add new, and we will go here in O1, and the information that has been given to us operating changes is jacket heating, which is duty, which we have already specified. The unit is kilowatt and the value is 150. And the stop criteria is that we want to run this batch for 1 hour to see how much changes occur or how much separation takes place. So now we will click on this run button, and obviously it will take maybe 1 minute or maybe 30 seconds. So now you can see the results are available. Obviously, I've skipped the part, edited it. So obviously it took me around 1 minute. So now we will go to first check the stream results, and we will now discuss the results one by one. And first thing is to check how much separation takes place. So majority of the methanol obviously will go to the distillate, as has been understood, because methanol is the light key. This is the separation that has been taken place in 1 hour. If we go to the time profile, you can see that with time, the temperature is increasing, pressure is obviously fixed in the system, duty is fixed, and you can see the vapor flow rates are fluctuating in the system. If you look at the composition profile with hour in the pot, obviously you can see that the amount of methanol is decreasing while that of the mole fraction of water is increasing. If we go to the distillation receiver, opposite trend will be observed. Obviously, the more methanol is going to the receiver part. Similarly, if we go to the profile results, we can see the temperatures profile, and if you look at the spot temperature profile, you can see that with the increasing time or with the time increase, the pot temperature is increasing. Even if you look at this table, you can see the trend. And this is the phase plate, which gives you the answer that once the cycle is completed, this is the temperature of the pot. Similarly, if you want to look at the other profiles, like if you want to look at the receiver composition with time, what has been changed is here, you can see that the amount of the methanol has been increased or kept almost steady. Or if you look at this table, you can see the amount of methanol and amount of water. And if you look at this phase plate, that after 1 hour cycle, this has been achieved. Similarly, for pot as well, if you want to look at the pot composition, so again, in the same way, you can see that the mole fraction of water is increasing while that of methanol is decreasing. And if you want to look at the phase plate, that after 1 hour, what is the mole fraction of methanol and water in the system. So similarly, there are different profiles which you can see over here one by one to generate more understanding related to the batch distillation column. So in this video, we learned how to simulate a batch distillation column in Aspen Plus for water methanol separation. We discussed charge specification, column configuration, operating parameters, temperature profile, receiver composition changes, pot composition behavior. Understanding these profiles is very important for analyzing dynamic separation performance in batch distillation column. If you found this tutorial helpful, please like the video, share it with your classmates, and subscribe to the channel for more tutorials on Aspen Plus, Aspen HYSYS, and chemical process simulation. Thank you for watching, and I will see you in the next video.